We're going to start. We're going to start with the, if you can see it, we're going to start right now. Don't forget, everything is recorded. We're going to start with the note well. It's a reminder about the process and policies, including about code of conduct, privacy, intellectual property right. You agree to follow them when you participate at the IETF and you registered. Please read it carefully. You are encouraged to read the source document to which the note well refers. If you have any question, you can always come to us, the chairs and the director of area. For in-person or remote, don't forget to scan the QR code so we know you were here, including for the remote participant. Reminders, there's also a queue. If you have any questions, put yourself in the queue and we'll be controlling the queue. In terms of admin, just as a reminder, we have a wiki and a GitHub. They are available online for operators to consult. Any presentation that the people are doing are posted on the GitHub. Working group status. We have one document that we will reach for adoption. We're going to discuss it today, the SRv6 deployment and the problem summary. This is our GitHub where all the presentations, like the two of this morning, will be posted afterwards for consultation. In terms of agenda, we now have two talks. We're going to divide the 35 minutes between the two talks. So Nick is going to come first and then Dan. And then we're going to move into the IETF presentation with those IETF draft. We divided the IETF draft 10 minutes each. Is there anything else we should add in the agenda or remove? Okay, so Nick, you are the first one.
Let's go to the slides. Stop the Oh, we have to take this thing back. That's why. Yes, and then stop slide. Just 1 second. Let's get your slides up first. Confirm. And then slide and then. Yes, it's yes.
So you're controlling the slides.
This one, right? Yes.
Yes.
Morning, I'm Nick Morris. I'm from Verizon. We're going to talk about some of the capabilities and possibilities with moving your SRv6 endpoints onto the host. I apologize for the thick Texas accent. I realize Google Translate doesn't work there. Just try to slow your thought process down and you'll figure out what I'm saying. So in general, today, the compute and the network are really disconnected as far as protocols. Once you kind of move the SRv6 encapsulation endpoints into the compute, it makes a whole lot more capable network as far as kind of the same across everything, at least in a utopia at the end. That's what we're trying to get to. And what we're going to do is talk about that possibility. So this really starts at like a 50,000 foot level. And I'm going to try to get down to, I don't know, 1,000 foot level or so. Not a whole lot of specific, but we will talk about some benefits of just doing this. So in general, today, this high level, you're looking, there's three kind of distinct domains here. You got the core, you got the edge, and then you got compute. And they're all kind of different. They present three different problems. You know, it depends on if you're configs or, traffic engineering, just different problems that are created by these three different domains as far as managing your whole network. So the first step, and I got it, is P1. Think of it as phase one, and a loose phase. So in the first phase, really what we're doing is we're bringing that edge compute and that, or the edge and the compute together to make it the edge compute domain. So this decreases some of those problems you have. The TE becomes easier. You get more standardized configs between the two different implementations. And it just makes it easier to manage automation wise or just manual configuration. One of the things that SRv6 gives you is now we can kind of abstract the core with the edge and the compute domains and make them look like they're all in the same, even though we know they're not, and there's different management in between. But it looks like from the core, from the edge and compute domain, like it's connected to the other edge and compute domain that may be on the other side of the world or in the next building, depending on however you connect across that core. So now your traffic engineering becomes easier. You can deploy it, as a single type configuration. And that's whether you're using PCE or Flex Algo, and we'll go into some of that in a little bit to get a little more deeper. It just appears like a flat network. And I think we've always wanted one big flat network. If we could connect everything up, make one big flat network, that would be great. Just too many cables, right?
Just one second. Joel, you wanted to ask a question right away?
Two clarifying questions. I'm not trying to disagree with what you're after. First question, are you assuming that the compute platforms you're talking about, the edge networks you're talking about, and the core network are all under control of one administration?
No.
Then you're violating the fundamentals of SRv6. And this is a very important point for you to at least highlight, because SRv6 must be within a single trust domain.
I disagree.
It says so in the RFC.
It's
not a question of...
It's how you're looking at it, right? So, and we can get into this. Do you want to get into it now?
Yes, this is the most important thing. Get into it.
So if it's different for a provider. Let's just say you're a small enterprise. You create your SRv6 domain here in Montreal. You've got another SRv6 domain that's in Vancouver. Well, you want provider X to connect those two parts just via internet. These domains going across here, it's just IPv6, but the domains look like they're the same domain.
Unless you're doing secure tunneling, which you're not assuming, you are violating the RFCs. I understand the use case you're painting. I understand why people keep asking us to do this, but you need to go back to, presenting this here is fine. I'm not objecting to that. But if you want to make that level of change in the requirements, that's going to have to be changed elsewhere in the IETF, because that is a very central, it was actually a demand from the IESG when we put forward the SRv6 RFCs. This was not something where some people thought it was a good idea. This was a very important part of the work. I'm speaking now as the co-chair of Spring. It's very important in the way we've been told to operate things. And if you want to change it, it's not that we can't change things. We can, but if you want to change it, we've got to go have that discussion in the right working groups. The other question, which now is less important, is I was not clear whether by compute you meant conventional hosts, VMs. Where in the compute stack you're trying to fold into your edge network?
Yeah, again, it's kind of generic because it could be different use cases, right? It could be a PNF that's got capability that it can do SRv6 NCAP and DCAP. I'm not saying they're out there. I'm just saying it's a possibility. It could be OpenShift, OpenStack. If you got some kind of KVM, it's not explicit in here. It's that you've moved that NCAP, DCAP out to the compute infrastructure, whatever your compute infrastructure is, and it starts there now.
If you want to go there, you're going to have to be very clear about the trust boundaries and trust models that make it work. I can believe it's useful. I'm not arguing with that part, but we're going to have to be very clear about how it's trustworthy. Thank you.
Maybe on this comment, and we could move on after your point, Jakub. From an operator perspective, it's the same domain. Inside the operator, there's many different little domains, but inside, that's what the RFC is saying too. Go ahead.
If I can, I was just, we have to delineate between the operational domain and the trust domain here, right? This is still same trust domain, but different operational domains, and that's
yes.
Yeah, that's right.
right?
Yeah.
So this is bringing them in, abstracting it to make it look like one so that you can control everything, right? Call it phase 3. One big network, everything in the world that's connected here is SRv6. It makes it so you have a single configuration. You can apply it across that domain. It makes the TE the same, at least, logically how it's applied, whether it's the exact same, doesn't matter. There could be slightly different requirements still in the core that there are from the edge of the access. But really it makes it so it's easier to automate, easier to operate, easier to deploy in general. Now we're going to go from that 50,000 foot down to more of a 500 or 1,000 foot level, right? So we talk about some of the protocols. This doesn't fit everybody. This is a generic, typical of what can be out there. And you look at this and you go, man, there's a lot of protocols out here, right? And there's different options on here, but none of them are really connected outside of their simple domain that they're sitting in. This is a management problem we have today that we would like to be able to fix with SRv6. So take the first step and we integrate that edge in the compute. So now what I've done is I've got a very single domain on the right or on the left and single domain on the right that are connected together through a core. The configs on the right and the configs on the left, they're essentially the same. Makes it easier to take care of, easier to manage. You get the same experience on either side. Now I've got two different things up here and somebody's probably going to ask about it. I say traffic engineering policies and then I show PCE. Essentially what I'm saying is, you could, whatever your TE is it flex algo? Is it PCE? That's each domain is going to have their own view of which works best for them. So I'm showing both options up here. Then you go to the phase 2, which is where we kind of kicked off the question before, how you connect these at. Here, you're essentially abstracting the fact that there's a core in there. You're making it look like that SRv6 because it is just IPv6 is connected and there's a cable there for that SRv6. Now you see the dotted line between the PCE that kind of connects it better. If you're using the TE policies, they're the same in both domains. What I'm saying with the PCE here is you have two different PCEs and they're federated in some way. This is a phase 2 option. Depending on your size and your PCE capability, maybe you have one PCE and you've implemented the same rules across the two different domains. That's all this is saying is just options that you could have, right? Again, flex algo wise, if you're using that, you just put the same policies on either side and keep it the same as you automate. Phase 3, this is the theory where it's all SRv6 all the way across from end to end, right? You see here, you got much less protocols than what we started with. Everything's simpler across the network. I broke up the TE policies and the PCE here, just kind of showing that you could still have multiple different PCEs or multiple different policies. They don't have to be the exact same, but they're still connected. And on the first slide, what you saw is a lot of different interworking, whether it was protocols or interface stuff, just different things. Here, there's not a whole lot of interworking. It's all kind of seamless across it, right? At the bottom, talking IBGP or BGP, whatever you want to do, but it's the same all the way from end to end. You can still break it up for scale reasons, but it's the same. You're looking at the same thing from end to end. This one, again, is more of a nirvana, right? Now you've gotten to where it's really like 4 protocols for your whole network everywhere. And the PC showing here is controlling everything for your network. Again, depending on your PC, scale problems, could be theoretical for you, but this is the most simplistic network we could have for providing service internally, externally, wherever it is, right? And you can take it to smaller scales. It could fit for different enterprises and different things depending on how you did it. Everybody's got different use cases. But I mean, this is, again, I think this is nirvana. You get 0 protocols different across the different domains and the same user experience anywhere inside of your domain, whether it's national, international, whatever. You good?
Have you evaluate how many processes between groups you're able to save with this phase or the phase 2 as well?
I don't know that we've evaluated processes between groups we're going to eliminate. We already had, just because of this, at least we've already went through a lot of that. As you bring these groups together, you just delete processes by using the same kind of stuff. So yeah, it definitely decreases workload between groups. It makes automation possible end to end, which is way easier as opposed to a bunch of manual touch points where you're handing off. So yeah, just a flat, less protocol network should bring benefits beyond cost of doing work.
Hello, thank you very much for your presentation. Tom Hill from BT. I recognize this kind of setup in the sense that you have core, you have edge networks, compute on either side. It's very familiar, and I feel like maybe there was a misunderstanding that, but probably would form one trusted domain within my organization if I look at it like this. The concern, I think, and you refer to this solution as Nirvana, and I think the concern that I have with this is actually nothing to do with SRv6 at all, and it's more to do with blast radius. I'm always in the back of my brain thinking, I know that we could do this, but should we do it? And I feel like we have enough examples recently of major systemic failure from widespread automation. Like, think about Meta having to cut the locks off their data center doors. Right. US East 1 fell apart because of DNS automation and various things like that. So what you have here is a very large blast radius. And so my question effectively is, what are you doing to mitigate against?
So I would say, yeah,
failures?
Blast radius is, anybody that's got a network of any size is always worried about failure domains and blast radius, right? I would say this doesn't create that any more or any less, right? If you look at the first slide, you've got different protocols that are talking together to provide the same services. If something goes wrong in one of those protocols, it can affect the network in general anyway. If you're saying that the blast radius is increased because you have a single protocol across the whole network, I would disagree. I would say anything in between can affect that, make the whole network a single blast radius.
Not so much about the protocol, genuinely, but more about the control of the network and the control of the protocols. And I think you're not just rolling SRv6 out across all of these domains. What you're doing is you're also rolling out the PCE control across all of these domains, which is something you can do. But the question is whether you should do it. And I look at this as I'm putting too many eggs in one basket. But, so the question is the same to both the original design that you had with lots of different protocols and different control elements. It's the same question now, but I mean, perhaps what I'm asserting is that by putting them all into one basket, you are increasing the likelihood that there will be a systemic failure.
I don't know that I necessarily agree with that as possible, but a lot of that is set up between redundancy protocols in the PCE and generic. This shows one PCE. Some of the other ones showed multiple PCEs. The assumption should be that you have geo-redundant or some kind of redundant PCE. When it comes to the flex algo, as far as the T policy, instead of using PCE, now you've got configs on the boxes, right? But it's the same theory. I don't think that necessarily increases your blast radius in any way, right? I mean, I know that people are afraid of PCE when you have a controller that might control, and then you say, well, something's faulty in that PCE. Now it could affect the whole network. Given possible, but any big error in SRv6 at that point might affect the whole network. Any problem today you have with DNS might affect the whole network. I don't necessarily think that any of this changes a blast radius. It's all about implementation and how you put it in. You're still going to have some kind of logical separation. Everybody should have that in some way, whether it's provided by redundancy or provided by some kind of segmentation. That's got to be a personal choice, right? As far as what fits your network and your users the best, I think. It's always a good conversation to have, and everybody should be having that internal to the network to figure it out. Yes.
Yes, I think it's incumbent upon us all when we design these Nirvana systems to think about how we mitigate against absolute disaster.
Yeah, I said Nirvana specifically because I would not want to say God box, which is like, right? God box scares people, and that's
We're
not
not in
what
Texas
this is.
anymore. It's okay.
Yeah, right. Yeah. So
That's good.
it's Nirvana as opposed to something that controls an overlording box, right?
Yeah, cool.
And that again, that PC could be separated by a bunch of different PCs that kind of serve as one layer, some kind of federation type thing.
We could catch up later. Thank you.
Can we move to the mailing list? We need to move on.
Yep,
Good
yep,
presentation.
All right.
Any
Thanks.
other question
Yeah,
in the mailing list or in the chat?
Tiny,
Right.
I'm in the queue as well. But very quickly, I think we would also love to hear where you are in the process right now in this all phases. Where are you currently looking? What is the scale that you have currently? That kind of practical information to the group would also be something useful. So share that in the list whenever you are comfortable. We will love to hear more what's happening. And just as a start, what Joel's saying, I think it's very important for us to, when we talk about this, to set that trust boundary thing up front. So it's good that Joel brought that up and clarified. Thank you. Second one. Clicker. Done? Yes.
We lost a bet. So releasing SRv6,
Done.
seeing it as more than so we're not working in the same company anymore. So we said, let's find neutral zone. So we use another operator as a neutral zone. So releasing SRv6, seeing it more as an MPLS evolution. So basically some of the work we are doing. Wait. Okay. So at BAL, we have a big modernization strategy. I think every operator has one in the world right now around how do we evolve. It's how do we leverage our strength in fiber, wireless, augmented with LEO. I think it's a storyline everybody knows. While we do it is how do we isolate methods to migrating while we migrate we reduce the footprint. Because when you realize that you're doing into network modernization, copper decom, all those things, you can reduce the footprint. So you can actually shut down locations or reduce the footprint of your central offices. Insane amount of savings, both on power, space, just like the amount of money you put on mowing the lawn or plowing snow. The trick is how do you get out of it in a cost-effective way? Reduce the investment, reduce the transformation, like the migration of existing circuits. How do you use that leverage to modernize your products? That's basically the strategy we have been doing. So instead of just refreshing a network and adding new technologies, new capabilities, how do we reduce we modernize our own network footprint, evolving the technology, and also product modernization, and how do we find ways of getting customers out of old services to the new ones? So that's a strategy. We have a NAS platform. I think the logic is around, again, I think it's nothing new in the industry. Everybody's trying to do it, is proposing some kind of NAS platform. We are doing this in multiple layers, changing the way we create products and business orientations. Having a bridge that can be able to abstract any kind of service construct and control, like the commerce part of it, into our existing network. And then we go into the actual abstraction of how you do the networking, both in the TMF type of NAS infrastructure. We are moving towards the autonomous network architecture. And to me, even if you do AI and you do autonomy and all those things, it's super cool. If you have to automate and transform chaos, it's still chaos. So we need to find a way to simplify the plumbing underneath. Having AI agents that abstract 17 or 57 inventory database system is not helping you in the end. You're just confusing everything else more. So we are really focusing on simplifying every layer. So we use, as you saw, the logic is around how do we build a service mesh or kind of a network mesh running SRv6 from many angles, cloud-based, on-prem, and in our network footprint. So how do we normally deploy SRv6 in network? Everybody tells us it's the most current is deploying is how do we evolve the existing type of service, L3 VPN, EVPN. Most replicate this typical pattern of CEP constructs. Every rationale is around doing a transition from an existing SR-MPLS network and transitioning it to how do we do the shift towards an SRv6 domain? How do we interrupt? How do we build large scale, like massive global scale SID space that's not going to break with the limitations we've got right now on the encoding schemes? How do we build scale across SRv6 across transport domains? So, for example, the question around like a control domain is still relevant. We always think like this. And how do we do that SID operation when you have contained into a single SID space? Because basically everything we do right now in industry-wide is, I have a SID space, I have to work within this, otherwise the interrupt is a different mean. Like you need to be in the same /24 or something like this. What if we change that? If we think differently about this? So we look at overlay logic around what if most operators right now have to deal with the fact that people are building SD1 services and trying to ask services. So what if we did the comparison across every traditional SD1 flavor that exists compared to an SRv6 overlay? From the technology, all the way we do insertion, traffic engineering, all those things have an implication. And we said, could we find can we use SRv6 as an overlay logic to build our services with the constraints everybody is talking to us about? So I will not go through all of this. You're going to be able to see them in the slides. So what we did is actually layered SRv6 over SRv6 or any transport domain. So we do an abstraction around the transport, keeping it opaque, so that the construct, like I don't want to increase the size of my IGP, I don't want to create more complexity. So basically, how do we leverage an SRv6 running over an SRv6 transport domain, or even if we can't, using existing 6Ps, 6VP architectures? We introduced the logic around like you know me, I presented the proxy last time, so the proxy is still there. We use the gateway functions when you want to interrupt transport data planes. Service completely is independent, you're going to see in a future slide. But basically, how do we leverage multiple SID space and overlay them as we need to, so we can scale without having to conflict and impact the other layer underneath. And we don't lose the benefits of SRv6. So I can do SRv6 over a flat, like a layer 2 network, independent, and tunnel it across. I will still lose some of the benefits inherent to SRv6. I don't have access to the IGP. But if I can overlay SRv6 over SRv6 like we did, then we're able to still benefit without like flooding the IGP or creating like security problems. We're still able to use its benefits. So what we did is basically we kind of an evolution of carrier supporting carrier. Can we run SRv6 over SRv6 and be able to use the logic of the SRv6 architecture to still be able to tunnel everything over? I could do transport over transport encapsulation, means I add yet another encapsulation. The beauty of SRv6, I could do a TE tunnel with just a 32 bytes insertion. The reason is, why does it need to be in the same SID space? We don't care. So this is what we do. So every independent domain of our business, like mobility or enterprise service, or somebody wanting to have its own network domain, could be running over without having an impact on the IGP. It still stays closed. It's just really basically doing a BGP free core in the time. It's kind of using the same logic. The beauty is around what we've been able to do with some of our partners is being able to do the correlation of an overlay tunnel in the next stop with an IGP, the TLV in the underlay, like the locators. So we're able to automatically create an IGP tunnel. We don't end up with crazy PCE and traffic engineering tunnels. And as you said, if underneath, you're basically running IPv6, but I just add an SRH header to run the overlay. From a layered architecture, I think the slide is ugly because it's too small. But what we are able to do is in both, our gateways are able to, some of our service gateways are able to talk multiple planes. So if they need to be available to across multiple planes, they can do it. And basically, we're able to transition for an MPLS transport to SRv6. Or if we get into a logic where we are running SRv6 over SRv6, it gets even simpler. The beauty is like, if you look at this from the diagram, it's actually clear. Most of the transport is basically pure IPv6 routing. Adding SRv6 at the underlay every node just adds you more capabilities, but in a lot of cases, it won't be needed. from a layered architecture, what we did also, which is quite interesting for us, was our network, like everything you know, this Salt Typhoon, how do you secure your network, how do you make all your devices rock solid? Well, we basically kicked the problem elsewhere. So our transport networks now is just becoming a locator router. We don't have any service routes, any internet routes that need to be on the physical plane of our network, only the border routers, because at some point there's still an insertion point. The rest, the service routes run in cloud control planes. We didn't do SaaS because, well, SD-WAN, Amazon failures, all those things, everything craps up. So we decided that the routing plane would remain local and distributed across our MEC locations, but the route services are independent from the underlay. So the underlay, basically, we have what we call the connectivity plane, which is physical. The reachability plane is how to make the locators talk to each other. And then the overhead is a service plane. And we secured it using eBPF. I'm a big fan of eBPF. So we use logic of application control, like layer 7 application control, to make sure that like our BGP speakers are actually more solid in that way. What we're able to do then, instead of what we had to do before, which insane amount of Ethernet tunnels to create like from a metro network to go to an IP plane network, and lots of internal circuits. When we do a transition, we don't migrate PEs, we don't migrate legacy routers, we don't really migrate legacy edge devices. They'll stay as they are. We can run from the old network, we can run the overlay over the SRv6 overlay as a 6PE architecture. On the new network, it's native. And then instead of having to do the transition of shifts in the night and all those things, we basically just shut the things down when the circuit goes away. So we basically created a mesh overlay over our network. For us, since it's supposed to be multi-cloud and multi-endpoints, we leverage as well. We integrated with what we had done, continuing from what Nicholas said. We had been working on integrating with our eBPF data path, our CNIs, which can run in multi-cloud environments. So basically what we did is we are just leveraging the same logic of if I'm able to do it from a CPE device at the edge or a data center workload, I can extend to the cloud using the same logic. In SRv6, in our cloud infrastructure, what we were doing is we talked about this being the locator auto-tuning, because cloud is actually applications are actually more flexible around how they play around with SRv6. Because one of the beauties of SRv6 that people still don't understand is if I was to do an IPv6 tunnel from an endpoint, if I encapsulate the traffic in an IP tunnel, I don't know that the other endpoint is actually it's a SID locator. I just know I've tunneled IPv6. So the same logic applies for cloud workload. So I just need to do an IPv6 tunnel. I don't know it's an SRv6 endpoint. It could be something completely different, but the end result is still the same. So what we did is, since we need to work around every kind of variations of locator support, we have the logic of being able to use locator auto-tuning. So we can adapt ourselves to every kind of locator space, as long as we follow the addressing architecture. I think Jacob is going to talk about it a bit later. We can optimize. I think the two hidden gems of SRv6 data path that nobody really understands is next up on change and RFC 9252 with sub TLVs and the PCID L3 attributes. A lot of other things are just how to carry existing MPLS networks into the new world, but those two attributes with an SRv6 network change completely the game, because then you can have a complete control plane separation from the forwarding plane, and you can work in auto-tuning the locator space depending on the requirements or the service you want. I have a slide around, which I don't have in that deck, that explains the logic around whether I do wide lib, wide gib, large scale. I think it's flexible, I think, from the design perspective. I think this is basically the end. The big challenge, I would say, that right now that still resides in how we deploy things, because we've so constrained SRv6 as being an MPLS VPN replacement, a lot of the capabilities of our mechanics that exist in IPv6 are still not used. For example, DHCP-PD, all those kind of things you could leverage correctly with an SRv6 domain, but we cannot do an MPLS. This is it. Locator space. For lots of host workloads and small devices, 48/48 F3216 is completely wasted addressing space. So allowing smaller scale of a locator space that looks more like combining the base addressing and UCID is actually the good thing. The third one would be UCID is still insanely in perspective, because if you look at this from a UCID perspective, with prefixed attributes, I don't really need, in a lot of cases, I don't really need traffic engineering to create architectural constructs and add inserts functions into the network.
Okay, done.
Yes.
Do you want to keep talking, or
No, I'm good.
want feedback?
I'm good. It's
Any
actually an hour
questions?
meeting, a presentation, but. Oh, you can go on the mic if you want.
Just say your name very, very clearly so that I can note it down. Yeah, on the mic.
All right, sorry, Jonathan from Metroptic. So Cilium uses BGP. Do you do you install routes in the kernel table, or do you use another mechanism to do that? Because
So you, that's one good thing I like from your question. I'm going to expand on this.
Mhm.
When you go to the United Nations and you have a delegation of people, not everybody knows every language from everybody in the UN. There's a translator.
Mhm.
So for example, in SRv6 domain and cloud domains, what we did is we have a BGP speaker that can talk to the rest of the world, the network, which is BGP based. The workers, they use the internals of Cilium. So they plumb in the policies directly into the eBPF I don't have BGP on every host to do it.
okay, good to know. Thank you.
There was one question which I posted on the list on the chat as well. What do you think will be the impact on the security and isolation of the workloads when we try to do SRv6, thinking especially from the SRv6 security draft that we are also doing? Is there any new implication that comes in?
Actually, the reason why we did this way is I would like to somebody challenge the way we can actually do micro security inside eBPF on an application level. Even with, if I don't do SRv6 and I do VXLAN tunnels, it's the same logic. I can secure so much more at the host level doing application that having an IPv6 tunnel or some VXLAN or GRE is actually irrelevant. It's your security paradigm changes completely. So either you isolate the planes like we did so that the security risk is flooding your IGP, or leaking the full internet route in an IGP and crashing your network, that goes away. The second one is the workload is basically push the problem somewhere else at the security level, which is, to me, is closer to the application.
Can you bring the question and comment to the list? We need to move on.
No, we have
Sorry.
3 minutes right
Huh?
now. It's okay.
I think you have the 2
Ron,
minutes. Ron, you have time?
We have time.
You may come back, Ron.
But the next time, please log in.
Okay, sorry. Ron Bonica, HPE. Let me see if I understand. The underlay solves the problem of traffic engineering. It gets traffic from PE to PE. The upper layer solves the problem of services. So in the underlayer, you're only going to see index SIDs, because that's all you really need, and encapsulate, decapsulate.
I can go back to a few slides.
It's going to be, just explain.
Okay, well, I can explain it. So the beauty of SRV is, so I can use multiple locators. I could have an Anycast SID done for services. That Anycast SID, just that Anycast SID, can be still on the IGP. So I have one SID introduced into the IGP, and I can use it from a locator perspective in traffic engineering. My destination on the data plane, like my customer, my service coming in, he's looking at the Anycast SID. I can do traffic engineering for it. Because I'm targeting that SID. The return is going to be based on where is my locator, but I have my IGP tunnel that shows me the way. So I can still benefit from this.
So in the underlay, you'll see many, many different kinds of SIDs.
You will see the underlay SIDs only, plus any kind of Anycast SIDs that you want to be able to expose, but you don't need to be in the same locator space. An IGP is an ISIS is ISIS. I can have like a different IP space in there. I'm not constrained into single one.
Okay, thanks.
Thank you. Thank you. Also, we are, like, as chairs, always looking for feedback on how useful these operator presentations are. At least from our point of view, these are pretty good, but we are always looking for feedback. And if you have ideas, when you talk to other operators, tell them about SRv6 Ops. ask them to come and present what unique thing they are doing. We are always open. Thank you. And let's move to drafts now. Mike. Have you transferred? Yeah.
So this is now a working group draft, and we received a lot of good comments during the adoption call, and we've been busy implementing that in the latest 01 version. We added Jacob Horn as a new author. He's provided some good feedback. And there was a lot of comments, and it was great. And we'll have more on the list that we need to do. We added things like updating a diagram that wasn't correct, and added path MTU, added some references, and inter-AS VPN types of additions to the document. So thank you again. Maybe one of the major things we did is we added a fourth migration option. Again, just as a reminder, the purpose of this draft is to document migration options to SRv6. And so that's what we're documenting. When we worked with customers and meeting with them, they asked for this kind of a document. And so we decided to have one here in the IETF in a vendor neutral way. So this fourth migration option is dual plane. And this is kind of some of the feedback that we need. And we have a few questions that we're going to use this time today to ask you questions so we can get some feedback, mostly on terminology. Dual plane is one of them. So right now we have the four options are ships in the night, and we're going to talk about that in a minute. Basically having logical control plane and data plane separation over the same physical infrastructure. The way we're using dual plane, and the way that one of the operators is using dual plane, is a completely separate network where they're rolling out SRv6. Overlay is using SRv6 over SRv6 infrastructure, and interworking is where you're stitching SRv6 domain and non-SRv6 domain together, which is being used at another working group, being specified in spring. So we need some feedback. And so these are the next slides that we'd like to discuss with you. We can either wait to the end, or you can ask questions as we go. So the first one is ships in the night. This came up again, to my surprise, during the adoption call of this term that not everybody was familiar with. And I've used this for decades, and many of you have used this for decades as well, thinking that it was a commonly understood term. It is a metaphor of just two ships passing at the night. They don't know of each other. And so I guess it can be confusing. It is used in several RFCs. So we have some options. We can either just leave it as it is and just explain it as we've done in the draft, or maybe we need to, at this beginning stage of this draft and this working group, is to use another term. You know, we can use coexistence or dual stack or something else. So that's the first question that we need to kind of resolve. The second one is there's been a lot of good operator information that, as the authors have discussed this draft and the different migration options, a lot of details about deployments that probably aren't appropriate in the main body of the draft, but it was suggested maybe we could put it in an appendix or in a separate use case draft. Okay, so that's the second question that we have that we'd like to get some feedback on. The other one is that currently we have this section that we are considering removing, and that is with a gradual versus direct migration. That we realize, as we've talked to some customers, that especially before SRv6 was standardized and mature, many customers were migrating to MPLS and then migrating to SRv6, and they were doing that for a variety of reasons. And if their network was already IPv6 ready, it typically made sense to just move straight to SRv6. So what we did add to the draft to kind of try to make everybody happy, at least some people, is that in most environments, it may be best to skip the migration to SRMPLS and migrate directly to SRv6. There's arguments for that interim step of going to MPLS, and there's arguments against doing so. Some of them are, argument for including that migration step is that, you're moving closer to SRv6 in terms of control plane protocols and service models. Then it's aligned with SRv6 once you decide to go to it. Again, you may not have IPv6, but you do want the simplification of segment routing in general. So, and you're already running MPLS, so you may want to just go to SR MPLS. And then if you do so, that transition to SRv6 becomes largely a data plane migration, not a full architectural rework. And this is an informational draft. It's not a best current practice. So, we should include all migration strategies in this informational draft. Arguments against doing so would be, we should be encouraging, as we do when we meet with customers, we should be encouraging people to migrate to SRv6, not SR-MPLS. This is the SRv6 OPS working group, after all. It doesn't necessarily move customers any closer to SRv6, at least with a dual plane approach. It adds unnecessary complexity and an unnecessary step. And it's a simple migration to SRv6. And so there's no real reason to migrate to SR-MPLS first. So these are the three questions that we have. And we're hoping to get feedback. Again, it's the ships in the night question, that term, do we keep it or change it? An operator use cases, and then this whole gradual versus direct migration discussion that we need to resolve before we continue on. So I'm going to open it up now. If you have any comments about any of those three questions, hopefully you have some opinions.
Please join the queue. While we wait for others, at least from my point of view, I think ships in the night, keep the term, but just explain it. I think that would be the best approach. And we'll hear from the other folks as well. This is just as an individual in the working group. We will see what the consensus is. With respect to operators' use cases, my personal feeling is keep the ID, focus on deployment options. And if there is a need, we can, as you suggest, we can always cover it separately. That would be my suggestion. Okay. I don't have a strong opinion on gradual versus this. Let's see what the working group says. Something which I think is missing in this one is, like, when we talk about migration, sometimes it's not possible to migrate the whole network towards SRv6 at one go. So what is the strategy that we should apply of which part of the network to move to SRv6 first, and why, and what are the things? That is also not just the final options, but what is the strategy that we should apply? That is also something which could be worth documenting in this document.
Good
just
point.
A suggestion.
Yeah, good point.
Yeah, go ahead.
Yes.
Yeah, I think actually, Drew, you may have made made almost exactly the same point. It's very interesting that there's almost a notion from the way that this was written. There's almost a notion that SRv6 is a natural progression away from SR-MPLS, for example. And I think I could sit there and debate all day whether or not it was worth migrating to SR-MPLS and then migrating to SRv6. I think probably what we should look at this, if you're going to write in anything about this whatsoever, I think it would be worth being very factual, but also thinking about the way in which Bell have looked at this, whereby they've had coexistence and being very factual about, does this actually benefit you? Can this benefit you? Could you just use 6PE, for example, until you can migrate to whatever else you want to do? But I would be very reticent to support anything that suggested that SR-MPLS is only ever a stepping stone towards SRv6.
Okay.
I think that's where I would kind of draw that line on what we should write down in an informational draft. I realize this is a working group for SRv6, but yeah, you should run what you want to run and what works well for your network. So
yeah, good point.
Yeah.
Thank
Tom,
you.
Are you just to be clear, Tom? Are you suggesting people should go from MPS to SR-MPLS and then SR-MPLS to SRv6?
No, I wasn't suggesting
it's
that.
the other way, right?
No,
There's no real meta.
I was saying that people should be running what they think is correct for their
Yes.
network and understanding what is the right option.
Yes.
There was an inherent notion that SR-MPLS is a stepping stone to SRv6. I don't think that's necessarily correct.
No, true, and you had it in your slide too, at the bottom.
Yeah.
Yeah, there's a debate there, right? I get that, but that was my opinion, and that's what I feel.
Yeah, it's a
would be
great,
best.
yeah, appreciate that feedback.
Thank you, Mike.
And the authors have different opinions on this as well, so we just need to make a, yeah.
Gyan, go ahead, but very quickly, please.
Yeah, can you hear me?
Yes.
Yeah, just a comment on the two ships in the night. So my thoughts were uh, that you could probably roll in the ships in the night with the dual plane. Because that's really like when you have two ships in the night, it's really the IPv4, IPv6 dual stack. So when you're dual stacking, you're creating the two separate planes. So my thoughts are you could probably, when you mention
Gayan,
dual.
can you check your audio because it's not easy to hear from you? And
Okay,
while you do that, we'll move to Nick in the queue.
okay.
Real quick, it's Nick Morris again. I'm probably going to echo kind of what Guyan was saying. Some of the stuff we use the term ships in the night frequently, and that's it's kind of what we're. So I have no problem with that usage. The one thing I would say is I feel like a lot of people skip some of the possible transitions. Right, we got classic MPLS, we got SR-MPLS and SRv6. Um, I feel like a big use case that's overlooked a lot is there's a whole lot of VXLAN out there that needs to be migrated to something else as we go along, and that should probably be taken into account is how do you go from VXLAN to SRv6, SR-MPLS, class, whatever you're going to do. And I think that's missed a lot as one of the big use cases for a lot of networks that aren't necessarily provider networks.
Very good point. We missed that, so we'll add that. Yeah, great point.
Gyan?
I turned up my volume a little bit. How am I sounding now? A little better?
Yes.
Okay. All right, great. All right. So yeah, what I was actually going to say was so with the ships of the night, which really refers to in my mind dual stacking when you have IPv4 and IPv6 creating the two separate planes. So I think that the whenever I guess in describing the ships in the night, I think you could probably make that part of the dual stack option. I mean, sorry, not the dual stack, the dual plane. So when you're doing dual plane migration, you could probably mention the ships in the night in that context. I think that would make sense. Um, and then just another quick,
He's an
yeah,
author.
another,
Talk to him.
yeah, just another quick comment as well is like I think what Nick Morris mentioned is a really good one. I know we talk a lot about MPLS and SRMPLS, but VXLAN is a big one, and there may be. I mean, those are probably the two leading, protocols, MPLS or VXLAN, in migrating to SRv6. So I think that's a really good one, and how to do that, and interworking, and the different caveats in migrating from VXLAN to MPL to SRv6. Thank you.
Thank you. I'll email you to get more done. Yeah.
Thanks.
Okay, next presenter.
Hello, Chess, can you hear me?
Yes.
Okay, thank you. Can you give the control for me?
Yes.
You have it.
No, you have to go and do this.
Oh, for remove.
Okay, got it. Thank you. Hello, everyone. I'm Yisung Liu from China Mobile, and today I will present the operational guide for the protection mechanisms in the SRv6 networks on behalf of my co-authors. This for the key updates history, and for the latest version of this draft, we have reduced the description of protection mechanisms, increased the deployment options. So we add the section 4.1 considerations for the protection. So let's overview of this operational guide for the protection summary. And for the protection, we have path protection and the egress protection. And for the path protection, we have the local protection like the RFA, TRFA, or the macro loop avoidance. And also for the path protection, we have the end-to-end protection like the SR policy, candidate path hot standby, or the B escape paths. And for the egress protection, we have the local repair for the VPFR. Also, in all of these mechanisms, we have to use the liveness check to detect the failure of the network. And for the local protection operations, we recommend to use the RFA or the TRFA, and we must use the define the scope of prefixes to be protected, and RFA or TRFA configuration options, and also control the interfaces to be protected. And we also use the delay calculation time, avoid the temporary congestion. The recommendation is the 5 or to 30 seconds. And for the multi-point failures in the network, we recommend that we use the shared risk groups configuration. And for the microloop avoidance, the default duration, we recommend that 5 seconds. And adjusting duration for larger networks along with the extended convergence time. So consideration for the liveness check, if the detection requirement less than the 100 milliseconds, we recommend that we use the BFD to detect the failure. So the BFD configuration can be reused to reduce the overhead. For example, we have a BFD for link or BFD for neighbor, but we can only use one session for that purpose. For the alternative detection protocols, we can use the TWAP or STAMP, but it's not unusual for the failure detection. For the end-to-end protection operations, we have a hot standby for the SRv6 policy, the primary and the backup paths. And we have failure detection for both the primary and backup paths. The reversion delay after the fault recovery, we recommend the 5 seconds. And we recommend that the multiple suboptimal paths for the sequential backup. So we also recommend that the escape to be paths if SRv6 policy or paths or candidate paths fail. So consideration for the liveness check, the detection time for inconsistent paths. For example, for the primary path, we can use the 50 milliseconds, and for the backup, we can use the 100 milliseconds. And we no bypass for the detection packets for the end-to-end detection. So for a single home, the scenario, we recommend the protection deploys as the TFA and also the multi-candidate path switch over as the end-to-end protection and the BE backup to TE. And the TRFA checked by the BFD for links and for the neighbors. And for the high SL cases, where we prefer use the end-to-end protection and only the candidate path switch over. And for the faster traffic restoring cases, we prefer use the local protection. And for the we also recommend the BE backup for TE, and when the multiple faults. For example, in this fig, when the link from the PE1 to PE and the P2 to PE4 both fail, so we can't use neither of the candidate paths, so we can use the SRB path. And but if we have strong SRA requirements, we prefer to drop the packets. So for the multi-home, the scenario protection, and we have a multiple egress PE. So for each egress PE, the same with the single home scenario. For the multiple egress PE, so we use the ingress switch over, so we can monitor the liveness of the egress nodes. I use the BFD for egress nodes, and switch over among the different egress nodes. For example, when the P3 fails, P1 can switch from the policy to P3 to the policy to P4. For the considerations for the MSD and the POS MTU here, when we use the enable the MSD strictest check, make the current node verify the MSD supported by the pass nodes, and it can if incapable MSD of any part prevent the label stack formation after enabling. So we can ensure the label stack compatibility with all pass nodes, avoiding the forwarding failures and enhancing the network of reliability. And we also should reserve the additional SRH length, because when we use the TRFA, FRR, and the macro loop prevention or the egress protection, or of these will introduce the extra space in the SRH.
Isong, are you there? Isong, we can't hear you if you're speaking.
Hello?
Yes,
Hello?
go ahead.
Oh, sorry, my network was unstable. Sorry.
Yeah, so I think let's start with the question. I joined the queue. Very general, high-level feedback for the draft. Right now, when I read the draft, it doesn't feel SRv6 specific. Everything that we are talking about protection seems pretty common to what we're going to apply for SRMPLS as well as SRv6. And as you know, within our SRv6 ops, as per our charter, we need to focus on SRv6 aspects only. Do you think there is enough meat in the protection draft where we could have things which are very SRv6 specific, or that's very difficult to figure out? Because I know that you have pointed things out, for instance, with respect to SRv6 path MTU, which are definitely specific to SRv6, but everything else sort of feel generic. What do you think? Am I reading this incorrectly?
From my point of view, because the protection, the protection deployment, the SRV MPRS and SRV6 are very familiar with, very similar with, for both. We usually use the same deployment policy for the SRV MPRS and the SRV6.
Yeah, Yusong. So I think let's discuss this offline. We need to figure out. We'll discuss this with Spring chairs as well. Like what's the best way we handle this. But yeah, let's get the feedback from others first on the content first.
Okay.
So next we have Rakesh, and let's close the queue and let's move to the next one after this.
Rakesh Gandhi from Cisco Systems. On slide 4, if you can go back to it.
Isong, can you go to slide 4?
Yes.
Yeah. So the considerations for liveness check. It's good to see the stamp there as well. It says recommend configure BFD for 100 milliseconds. So just wanted to highlight that if you use stamp, for example, you get latency loss and liveness, and you can also get the detection less than 100 milliseconds as well with stamp as well, just as a consideration. Thanks.
Thank you very much.
Thank you. Let's move to the next. Take the control. This is for slide. Okay. I think you have given it control to PS. Stop. 3.3 OM. Possibly out. No, this way. Yes, you have the slide control.
Okay, thank you. I can control. Hello, everyone. This is Lian from China Mobile, and I'm very glad to present our draft. This draft summarizes the issues that need to be considered in the deployment process of SRv6 OEM. And this is the first time presentation for this draft. And first, I would like to briefly review these two fundamental methods of SRv6 OEM. And the one is the SRv pin. It works as a heartbeat check and verify connectivity and host reachability by sending a probe and waiting for the reply. And the other is the SRv6 trace route, and this acts as a path tracer, probes the network hop by hop, helping us map the complete path topology and locate exactly where a failure has occurred. With these two methods, we can achieve the two major detection targets of the SRv6 network. First, the SRv6 seed and the locator reachability. This is used to check if every individual address in the network is reachable and whether or not it can be forwarded correctly. And the second, the segment list and policy validation. This ensures the integrity of a predefined path and verify that every segment of the explicit path is open and functional. So together, these two targets ensure the quality from the basic network layer up to the advanced service. This page discusses the deployment considerations from three aspects. First is the initial points, and the second is the detection granularity, and the third one, detection path. First, the initiation points based on the network device roles. This involves three types. The customer edge device, we call it CE, and the provider edge device, PE, and also the core device, P. And from the CE device, the OEM detection only support the end-to-end service checks and using the standard IPv6 pin or endpoint DT4 seed with target PE. And from PE device, the capabilities are more stronger and support both service detection and the tunnel level detection. And especially for the service detection, it can simulate the CE perspective also using the endpoint DT4 state in calculation. And for the P device, the crucial requirement is the ability to process the SRH, including both the comprised and non-comprised seeds. And also it should generate a correct error message when an issue or fault is found. And the second aspect lies on the detection granularity. It's very easy to understand the hop by hop and end to end. And the hop by hop is suitable for the troubleshooting issues, and the end-to-end verifies the overall connectivity from source to the destination. And finally, the detection path also for the BE and the TE path, the OM solution should support. And there is another situation is that when a policy has multiple candidate paths, we need the ability to test them in parallel. For example, we should using the different flow label or DSCP markings to identify the different segment list. And this slide covers some key technical considerations. I will go through it faster because of the time limitation. And first, the encapsulation mode selection, also for the encap mode and the inner mode. And also we should consider the compressed mode. And the second one about handling the asymmetric path, the forward
Liam,
and
we are
yes.
still seeing slide 3. Are you talking about content from slide 4 now?
Okay. Oh, sorry. I have bad signal. So
yes, go ahead now.
Okay.
And look at the time. I think try to conclude so that we can have some questions.
Okay. I know it. And the asymmetric path related to the false and return path of the OEM detection. And the third one is the path MTO, and we should support this. Also, the last one is the BC, the stitching. This requires the intermediate nodes to have the ability to proxy forward the SMP message so that the head end becomes aware of the failure. Also, there are some advanced scenarios, for example, for the EVP and the network slicing. I will not detail it here. Yeah, and next page. We skip the last page, and finally, I want to mention is that we have covered quite extensive content on the presentation follows the logic flow of what is where it's used. And
let's take questions. We have run out of time. Zafar, please quickly.
Yeah, I think my comment was about some of the binding set content that were there. So as such, you can ping and trace a binding set because upper layer, if that's the target, then the upper layer will get terminated on the binding set, and you are able to do that. If you have a different domains and you don't have a reverse path, then you have an issue, but you can specify reverse path there as well. So if those kind of details can be clarified, I would appreciate that.
Okay, thanks. Rakesh?
Okay, thank you.
Rakesh Gandhi from Cisco Systems. On this slide, the encapsulation mode, encap and insert. So there are other drafts for PM and BFD in Spring Working Group that define the encap mode and insert mode and use it. So maybe it would be good to align the terminology and what that means with OEM as well. So that's one comment. And then the previous slide, if you can go back about the ECMP part, path ECMP. So here it says that when SR policy has multiple segment lists, you use different flow labels. I think what consideration should be that with the flow label, you still will not know which segment list has failed, right? You don't have a way to influence the segment list path. So maybe something to elaborate. Thanks.
Yeah, thanks. Rakesh, give text. I think you are an expert, so send that information out on the list. That would be really useful. Thanks.
Okay.
Let's move to
Thanks.
the next.
Okay, thank you.
Thank you so much. Frank, you have the slide control? Yes, go ahead.
This is Feng Yang from China Bio. Yeah,
Yes, go
okay,
ahead. You
okay.
have
Yeah,
5
this
minutes.
is Fuyang from China Mobile, and I will introduce a policy SRv6 policy selector. And can you see the slide 2?
Yes, we see slide
Okay.
2.
The motivation is that RFC 9256 defines the composite SRv6 policy, which can include multiple SR policies with different colors. Different applications can then be carried by different member SRv6 policies. However, when a member SRv6 policy experiences performance degradation or failure, the switching or the protection mechanism has not yet clear at this moment. Here we call the composite SRv6 policy as a parent SRv6 policy in order to clearly reflect the hierarchical structure of the policy. So the revision history is that the proposal has been presented on the 115 in Spring WG. Since this proposal has not any protocol extension, so we have moved it to SRv6 OPS in last meeting, and also do some updation per comments from chairs. So we define we define the SRv6 policy selector into in the parent SRv6 policy. The SRv6 policy selector determines the failure and performance degradation by receiving the best quality measurement metrics. Those measurement metrics can be get from the either of the BFDT1 or something else. So a parent SRv6 policy can have multiple SRv6 policy selectors. Then different traffic flows are mapped to corresponding constituent SR policies, where these selectors only here in this one only one selector is shown in this diagram for the simplicity reason. So each selector defines two parameters: threshold and the priority. Threshold specifies acceptable path quality for an application, such as latency or the packet loss. The priority defines the selection order of the SRv6 policy for the application, and a measurement window needs to be defined. If quality metrics change within this model window, a set of SRv6 policies that meet the threshold is identified. If current selected SRv6 policy still within this set, no switching occurs. Otherwise, the member policy with the highest priority is selected. If none of them meets the requirement or the threshold, no switch occurs and an alarm should be triggered. So we consider the application. So there is some problem with the network. So we just talk this page. So consider there is two applications, one conference and one CRM. So you can see we have the parent SRv6 policy and the constituent SR policies, and the selector just steering the different kind of applications to the constituent parent policies. Such kind of measurement involves multiple samples. The threshold should be interpreted as a statistical value, such as average latency or the average loss rate. So next step, and this has been already implemented on the H3C routers. So next step, we are seeking the comments from the working group. If there are no objections, we would like to ask for adoption. So that's all.
We'll take questions. That was super fast because we need to move.
Yeah, very fast. So same comment that Lou has on a different draft. This is not SRv6 specific. This is generic, and RFC 9256 also already talked about composite candidate path. There are solution drafts in PC and IDR in this area. So I think we need to do some kind of alignment. Thank you.
Yeah, thanks.
Jacob, last presentation of the day.
Good morning, everyone. Jakub Horn on behalf of Carters. Thank you. On behalf of Carters, I would like to share our 6 years experience with SRv6 addressing. So basically, what is the motivation? Well, the main motivation is really to share our experience, because we are working on SRv6 in many deployments around the world with the network of different sizes. So we got certain experience already, and we wanted to share with the wider community. And obviously, IETF is a best place to do this. The SRv6 addressing has to be flexible in a sense. It has to be extensible, because you never know what's going to be grow of your own organic grow or joins. Has to be very well summarizable. Because you want to have really efficiency in terms of the size of the underlay routing tables. And all those things are obviously important to maintain, even if you're using the compression of the SRv6. There are different addressing schemes, well, and we will touch upon that a little bit later, which can result in very inefficient traffic engineering. So we want to really describe the best practices and our experience here. So first of all, it has to be simple. Everything in SRv6 is supposed to be simple, and addressing is no different. Well, simple addressing makes simple network, makes simple operation, makes simple everything. Summarization is utmost principle of SRv6, so has to be really done properly. And has to be, and this part is really often overlooked, has to be efficient in terms of the traffic engineering. The draft focuses on F3216 format, but it's totally applicable to any other CSID format as well. In terms of the addressing, again, draft is not explicit. Well, it supports any addressing range, ULA, where the most current deployments are. It supports global addressing with all the advantages and disadvantages, and obviously it supports and uses examples in 5F space, which is the SRv6 dedicated space with all the same properties as ULA. Question right now or after? What is the preference? I can take it anytime.
Just one quick comment. I would be careful about Nick Braulio with ESNet. I would be careful about saying that the 5F00 has the same properties as ULA, because it doesn't. And I think that ambiguity will be problematic later, so I would suggest.
Agree. That in that sense, I agree. I'm meant in 100%.
Thank you.
Agree. Yeah, thank you. So this is the format which we call 3216. So the block is 32 bits, and the 16 bits is each individual microsits. The addressing, as we are proposing, is using really this format, but it's obviously applicable to logic is totally applicable same way in any other format which will develop in the future. It is important right now, all the deployments are really following this format. All the interrupts, ENTC worldwide, everything was done using this format. Well, I'm not saying it's not going to develop in other formats, but right now this is the totally predominant and common format. This is the part which I personally consider really important, is T efficiency. If you don't do your addressing plan properly, you really fulfill all the simplifications, you have all the encoding everywhere, you do the addressing in a way that you use the multiple block and your T policies are crossing those blocks, there is a difference in first 32 bits, you will result in a SRH because you cannot really use the compression, right? Or each microseed has to be located in different container because the block is not a common. So this is like the worst case example. So if you want to do the traffic engineering with the six seats, you can you can do it if your addressing plan is done properly. You can have the encapsulation, just the IPv6 encapsulation, just 40 bytes. And if you are not this efficient, you can easily end up with 128 bytes of encapsulation because you are crossing the blocks and you have to split each microseed to different containers. And this is really important. This is, for me, this is the main motivation of the addressing plan. And people usually don't realize that. So single block, small network, and we try to make different distinction how to address the different network of different sizes. And the first network is a small network. And the small network for me is any network I can address within the one single locator, within one single block. So single block has unique because microset is 16 bits, the single block can address up to 65,000 unique microset. There is a default split between GIP and LIB, and the default split actually says there is a GIP size 57,000. So I'm already removing 8,000 from that range for the local seeds. It can be changed. It can be flexible, but again, common deployments are in this range. So I can have small network would be 57K, and based on our experience, rule of thumbs, because of summarization inefficiencies, you have to do certain summarizations in certain areas. Our experience is that reality is close to 35,000 devices can be still considered small network and still can be addressed from one single block. We introduce here the concept of the sets. Sets, it's a logical separation of that addressing space for the locator, and it is basically it can be of any size. Typical example is /40 because there is a nibble boundary, and the most deployments are using /40s, and you basically assigned different sets to different regions. That set is not just for assignment, and it's also for summarization. This way, you will achieve essentially the more flexibility because you don't need to pre-assign the bigger or larger number of sets to different area, different regions, and you can do it basically organically how each part of the network is growing. And if you preserve the summarization on that set boundary, you don't really need to plan anything in advance. You're just assigning the sets to the different areas as the areas are growing. And your routing table is kind of nice because it contains only /48 for the local locators and /40s for all the other remote locators. Then flexible algorithm addressing is important in SRv6, as everyone here knows. You need different locator per different flexible algorithm you're using. Obviously, there are a lot of possibilities. In theory, you can mix and match. You can do addressing of two flexible algorithms from the one block. We strongly discouraging that. The main reason for that, if you use the same block across multiple flexible algorithms, you have to share local ID blocks. So you're reducing service scalability on every single device which is using those algorithms. So by default, you recommend to use different blocks per different flexible algorithm or algorithm in general. No matter how large your network is, always use different block for algorithm. Last but not least, obviously, not all the networks fits under 35,000 boundary. So we have much larger deployments than 35,000. And obviously, we still want to preserve that scalability or that traffic engineering efficiency. So basically, large network, we encode the kind of regions, and those regions doesn't have to be necessarily geographical regions, has to be a region which essentially contains just 35,000 devices, and boundary doesn't need to be really geographically aligned. That number of region each network needs is really basically size of the network divided by 35,000, right? Because you use per one to address within one single algorithm multiple times 35,000 devices. Again, for the simplicity here, well, obviously anything is possible, but for the simplicity, we are trying to use nibble boundary of IPv6 addressing. So what we consider a large network is just the network which is like 16 regions, 16 times 35,000. This way you can address the network up to roughly 5,000 devices. And there are networks which are very large. And then you need basically 1 byte to enable us to declare the region. And in that case, you can address network up to 8 million devices. Obviously, with 5F or with ULA, you can go beyond this, well, but we don't see currently any necessity to do that. I'm just about to finish. Important thing, algorithm encoding is always in a higher order bits than the location, than the region. Questions, please.
We have
just one, Jeff. Go ahead quickly, please.
Hi, thanks for the presentation. So I know where you're coming from. F3216 has been kind of default implementation. And as long as you're looking kind of service provider environment, I wouldn't say it makes sense, it's okay. Coming from data center space, it's actually harmful. I would really like us to focus on F1616 because of really lack of education. People actually deployed F3216 and it's still kind of hitting them. So I would really like you at least to put DC kind of paragraph here that would address requirements for data centers. And maybe it's a good time to switch to F1616 altogether. There's no performance benefit. There's nothing that makes you use F3216.
Tom, quickly, we are over time, so quickly, Tom.
The title of this is SRv6 addressing, but it very quickly makes note that this is only for next CSID. RFC 1980 9800 includes 2 flavors. So
that's correct.
Could we clarify this in the draft that it's is there because there isn't one single flavor, so either you need to change the name of the draft or you need to account for replace CSID as well.
An addendum to that, like we should also have addressing without compression as well, like
that would be actually even better. Yeah, no, that would be good.
I think vast majority of deployment, almost all deployments are currently using this format.
That doesn't matter.
I'm okay with that.
There are many ways to do this.
My intention was really focus on this format because it's widely and mostly deployed. And
then you certainly must change the name of the draft because it can't speak to all addressing mechanisms.
I'm fine with that.
Yeah.
And our fathers use it is not a good technical argument, right? So let's look at reality and where we are today.
Okay, and to second question, we obviously foresee the need for the different formats like 1616, 4816. Everything is possible. We can add some paragraph more to mention that, but if the microSID stays the 16 bits, which I consider very likely, I think all the applicability of this addressing plan basically stays identical, and we can put the stuff.
Thank you, Jakub. We'll close the working group. If there is more question or comment, please use the mailing list.
Thank you very much.
Thank you.
Thanks everyone. Thanks. Sorry for running a little bit over.
Yeah, thanks everyone.
Good.
Yes. Sync up more on what happened right now.
Always. I have an 11 that I'm getting late to. Already 4 minutes late. Okay.
Voilà,